What if we could raise the Titanic not by lifting the wreck, but by making it lighter so it could float again? This is the premise behind proposals to pump expanding foam into the deteriorating remains of the legendary liner. By displacing water with buoyant foam inside the hull and compartments, the Titanic could theoretically float again. The physics behind the concept is simple. Polyurethane and isocyanurate-based foams contain inert cellular pockets that make them less dense than water. If enough of this buoyant material permeates the volumes within the wreckage, the overall density is lowered. According to Archimedes' buoyancy principle, this reduced density could provide sufficient upward force for the 46,000-ton Titanic to lift off its resting place. However, safely executing this technique on the real wreck introduces serious hurdles. Transporting the expanding foam material down to the site in the massive quantities needed already poses an enormous logistical problem. The foam components would need to be mixed and pumped through miles of heavy-duty flexible hosing robust enough to withstand intense deep-sea pressures. Installing this sprawling foam injection network on the seabed entails its own risks. Once the complex injection system is in place, achieving an ideal foam distribution throughout the interior wreckage presents the next challenge. The goal is to completely fill void spaces within the wreck without weakening her structure. But the Titanic's interior layout is a complex maze of compartments and passageways, some fully collapsed. Sonar scans and interior footage would help target foam injection points. Careful monitoring and control over the foam injection would still be needed to avoid high-pressure buildups that could rupture century-old bulkheads. As the expanding foam permeates the wreck, its buoyancy gradually increases, eventually floating the Titanic off the bottom. But this liftoff must be controlled to minimize sudden motions or snapping stresses. Crews would attempt to closely track foam volumes and injection rates and make adjustments to produce a smooth ascent profile.